In this video, I'm going to go over sample solutions to some of the problems on calculating the confidence interval for the population proportion. So let's start with problem number one. This problem is inside in your textbook, and we're looking at section 10.2. So let's go over that now. In problem number one, we're looking at a random sample of 500 cars. It was found that 150 of them were colored silver. We have to calculate the sample proportion P. So to do that, P hat is equal to 150 over 500, and that's the same as 3/10, 0.3. At the 95% confidence interval, calculate the margin of error correct to 2 decimal places. So for this problem, I'm told to use a margin of error approximation E equals to 1 over root n. So in this case, that's E equal to 1 over root of 500, and that equals to 0.44. And remind you that n is the number of objects in the sample. And finally, we have to construct a 95% confidence interval for the proportion of all cars that are colored silver. So remember that for the population proportion, it's P hat minus E, which is less the value of the population proportion, which is less the sample proportion plus the margin of error. Let's put the values in. 0.3 plus minus 0.044 is less than population proportion is less than 0.3 plus, again, 0.44. So once I subtract and calculate, I get that proportion lies between 0.256 and 0.344. So then the next one is problem number 7. So for problem number 7, again, I'm using the margin of error approximation equals to 1 over root n. So reading the problem, I'm told that a survey was carried out in order to gauge the response to a new school healthy eating menu. Random sample of 200 school children. So this tells me that n equals to 200 was selected from different schools. It was found that 84 children approved of the new menu, which means that I can calculate the sample proportion equal to 84 divided by 200, which is 84 by 200, 0.42. So now, based on those values, I have to construct 95% confidence interval for the population proportion P of the students who approved the menu, exactly the same way. P hat minus E is less than P hat plus E. Sample proportion minus margin of error less than population proportion less than sample proportion plus margin of error. Let's calculate margin of error. E equals to 1 over root n, in this case 1 over root of 200, which gives me the value of 0.071. So substituting the value in, I get P hat minus 0.071 less than P hat plus 0.071. And when I do the calculations, 0.42 minus 0.071. So let me just replace P hats with 0.42, which turns to 0.349, less than population proportion less than 0.491. So that's the confidence interval. And we can move on to the next problem, which is number 9. And in this case, I'm actually going to use the more accurate formula for the margin of error, which is equal to 1.96 root of p hat 1 minus p hat divided by n. Cool. So in this problem, I'm told that a manufacturer wants to assess the proportion of defective items in a large batch produced by a particular machine. He tests a random sample of 300 items. That tells me that my n equals to 300, and he finds 45 that are defective. So we have to find the 95% confidence interval. So first thing I'm going to calculate p hat sample proportion equals to 45 divided by 300. When I chuck it into the calculator, I get the result of 0.15. Then using my margin of error approximation, I get the value of 1.96 in the square root 0.15, 1 minus 0.15, substituting the value for sample proportion divided by the number of items in the sample, which is 300. So when I calculate this out, 1.96 multiply by square root of a fraction of 0.15 times 0.85 divided by 300. This is equal to 0 0.04, and that means that the population proportion between p hat minus e and p hat plus e, substituting the values in, 0.15 minus 0.04, p 0.15 plus 0.04. So that means that the population proportion lies between 0.11 and 0.19. And last example for the population proportion is this one, problem number 15 from the same section. In a sample of 400 shops taken in 2012, it was discovered that 136 of them sold carpets at below the list prices. So that tells me immediately that n equals to 136. We have to estimate the percentage of all carpet selling shops selling below the list price. Sorry, let me just correct this, because obviously I think I'm noticing that error. I know that n is equal to 400, and p hat equals to 136 divided by 400, which is equal to 36 by 400, 0.34. So we can calculate my margin of error approximation. E equals to 1.96 square root of p hat, which is 0.34, 1 minus 0.34, all that divided by n, which is equal to 400. So, and I do this calculation out on my calculator. 1.96 multiplied by square root of a fraction of 0.34 times 0.66 divided by 400. The result is 0.46, 0.046 rather. So then the confidence interval is given by 0.34 minus 0.046, 0.34 plus 0.046. So carrying this calculation out, we get that the lower limit of the confidence interval is equal to 0.294, and the upper limit of the confidence interval is 0.386. So then nationally, it is known that 34% of the shops sold carpets at below list price. what size sample would have to be taken locally in order to estimate the percentage to within 2% of the population? So this in this part of the question, this is the important value, and that value tells me that the margin of error rather is 0.02. So the proportion is 34, and the margin of error is 0.02 because 2%, within 2% of the population, plus or minus 2%. So that's what my margin of error is, equals to 0.02, but I also know that this is equal to 1.96 root of p hat minus, multiplied by 1 minus p hat divided by n. So in this case, I'm going to say that p hat again is equal to 34, 0.34. So we want to solve this equation to find the value of n. So when I do my transposition, I'm finding that n equals to 1.96 square multiplied by p hat 1 minus p hat, all that divided by e squared. Substituting the values in, 1.96, 0.34 by 1 minus 0.34, and below the value 0.02 squared. So let me calculate this quickly. Obviously 1.96 has to be squared as well. 1.96 squared multiplied by 0.34 by 0.66, and all that divided by 0.02 squared, which gives me the value of 2,155, 2155.13, which approximates to 2156. Cool. And that's the last problem in this section. So thank you for watching.